Today we'll be looking at number patterns, grade 11. Now in number patterns we'll be looking at the two types of number patterns, which is the linear and the quadratic. But firstly we'll be looking at the linear number patterns, which has the general formula of Tn is equal to Bn plus C. Now we'll be taking the first example as to work out a linear number patterns. Okay. Right. Now we'll be looking at the first example. Now where it says consider the following linear number pattern, which we've got 2, 7, 12 and 17. Now we'll be looking at the first example. Let me write solution here. So we've got 2, 7, 12 and 17 and then so on. So this one, it represents the first term, second term, third and the fourth term. Now the first question says we must determine the nth term and hence the 19th term. When they say nth term, they mean the formula. We have to determine that formula. Okay, so now before we do anything, we have to get the constant difference. Okay, so how do we get the constant difference? So I would advise you guys to use this formula: T2 minus T1 is equal to T3 minus T2, so that if you are given the terms which maybe all of them are negative, or maybe one of these terms is negative, and then you'll be able to see and simplify that term with the negative sign. So now we're going to say T2, which is 7 minus 2, and T3 is 12 minus 7. And then 7 minus 2, of course, it's 5, and 12 minus 7 is also 5. So that means the constant difference is 5, 5, 5, 5. Remember, they say it's a linear, meaning that the first difference here is the same. So now we are done now to find that is the constant difference here, which is 5. And then what we're gonna do here is that we're gonna just take those general term, which is Tn is equal to Bn plus C. Now it's easy because that 5 over there, so this 5 over here represent the value of B. So you just take that 5 and then you just write it over, you just substitute here. And then now the next thing is to find the value of C. So that means now we've got, just write it aside, that means here we've got B is equal to 5. So then now the next step is to get the value of C. How do we then get C? It's easy. You say B plus C is equal to the first term, which is T1. So you use that formula. So we're gonna be B plus C is equal to T1, and B we've just got 5. So it must be 5 plus C is equal to T1 is 2. So that means 2 minus 5, the answer is -3. So you just substitute here. So that means the formula is, it says Tn is equal in the place of B, I'm going to put 5n minus 3. So this is the formula that we were required to calculate in the first question. That is number A. So now it's easy to get 199th term, or we can also look out the second option for this question. Now you can use the second option. So let's say this one over here, this is option 1, and then in option number 2 So let's check how do we then get this formula by using the second option. So in the second option, we're going to use this formula. Tn is equal to a plus n minus 1 times d. So where we know that the difference between each term here is 5, so that means the place of d we're going to put 5 here. So, and then the value of a, it's easy, which is 2. The first term is given to us, so t1 is the same as a. So we're gonna just substitute. Let me just put those values over here. So a, which is equal to t1, so they are also equal to 2, and the constant difference is 5, and then we just substitute. So in the place of a, we're gonna put 2 plus n minus 1. In the place of d, we're gonna just put 5, and then we multiply it out. So when we multiply this out, so it's going to be 5 times n and 5 times 1. So what do we get? We first drop 2, 5n must be plus 5n, and then 5 times negative 1 must be negative 5. And then we bring this one up front because it has a variable which is 5n, and then 2 minus 5 must be negative 3. So that one is tn. So you can see that those this one is the same as this one. So meaning that you can use the second method, or maybe you can use the first one. So any of the two, as long as you are comfortable maybe with the first one or the second one, no problem. And then now let's look at number, or in the same question, but this part that says hence determine the 19th term. So that is, now what do? We're going to use this formula over here. We're going to use this equation. So in the place of n, we're going to put 199. So t199 is equal to 5. If in the place of n we put 199, also here we're going to put 199 as well. So 1919 minus 3. So then you just work it out, and then you get 992. So this is the final answer. This is T199. So now let's look at number B. They say which term of the number pattern is equal to 497. So that is in number B. What we're gonna do here is that when they say which term, it means that they are asking you to determine n, the number of terms, and then you are given that tn is equal to 497, and then now it's easy, you just use this formula over here. So meaning that you must make sure that you work out this formula correctly. Okay, so we're going to take this form, must be tn is equal to 5n minus 3. So in the place of tn over here, we're going to put this value, so that must be 497, and then must be 5n, and then minus 3. And then we just bring 3 on that side, it is negative, and then we change the sign, become positive 3, and then we're left with 5n, and then we divide by 5 in both sides. Therefore the value of n here must be equal to let's just work out this portion. So because we're gonna have 93, we're gonna have 500 divided by 5 must be 100. So that is the term number 100. So this is the answer. Done with this one. Now let's look at the example 2. Now in this example we are given -6, -10, -14, and let me just draw a line here, which is example 2. Solution. Okay, so given that negative let me just double check here, -6, okay, and 10, -6, -10, -14, what is it, 18? Oh yeah, it's 18. So -18, and therefore now we do the same here, guys. We find the common or the constant difference. Now the first question says we must determine nth and hence 600 term. So we're still looking at this formula. So the first step here is to get the constant difference. Like I said, that it is wisely to use this formula that says T2 minus T1 is equal to T3 minus T2. So where T2 is negative 10, negative into negative 6 is equal to T3 is negative 14, negative into negative 10. So negative 10, negative and times negative become plus 6, and negative 14 plus 10. And then negative 6, we subtract those two times, we take the sum of the bigger number, must be negative 4. And then 14 and 10, of course, is also negative 4. That one, it is a constant difference. And then now that we know the value of A, which is negative 6, and then we know the value of D, which is negative 4. So we know that it's negative 4, it's negative 4, negative 4. So I said to now to be able to get, let me just write them down here because it's gonna just make this one dirty, or maybe just over here. D is negative 4 and A is it's negative 6. So the formula now says Tn is equal to Bn plus C. So I said it's always that one, B. So that means we save in terms of this negative 4 and plus C. So to get C, just say B plus C is equal to the first term, which is this one. So that we can just work it here. So this B plus C is equal to the first term, and then B is negative 4 plus C is equal to negative 6, and then we just collect like terms plus 4, and then the answer must be negative 2. So we just say therefore negative 4n minus 2. So this is the formula that we require to calculate. Now I'm not going to use second option in this question as well. Okay, so I'm going to just take one option as long as I showed you in the first part. Now let's go straight to hence calculate the 600th term. So it's easy, we just use this formula over here. So that says Tn is equal to negative 4n minus 2. Now in the place of n we put 600 minus 4, and then we also put 600 here as well minus 2, and then we just work it out. So we can use our calculator just to check that. So it's going to be negative 4 times 600 and then minus 2, and must be negative 2004.02. Must be negative 1002. Must be negative 2402. Let me just confirm that. Oh yes, 02, that's correct. So we've done now in the first question. So we go to B, number B, that was A, and then B says which term of the number pattern is equal to those portion. It's easy, guys. We just use this formula, the one that we've obtained in the first question, the formula that says Tn is equal to negative 4n minus 2. So it's actual says that in the place, now we are looking for n, but in the place of Tn we're going to put negative 442. Let me just confirm that it's negative 442. Yeah, negative 442. So that means over here we're going to put that negative 442 and then negative 4n minus 2. Now we are solving for n, so we just take negative 2 to that side. So it is negative. When we transpose change, the sign become positive, and then we just work out this portion. This is negative, and 2 must be negative 440 over negative 4. So you'll have to divide by negative 4 in both sides. So therefore the value of n must be equal to, let's just double check this one on our calculator. So we've got negative 442 plus 2, and then divided by negative 4. So it's 110. That's perfect. It's 110. So the number of 10 must be 110. So we have done now with these 2 examples. Now we go straight to quadratic number patterns. Now let's look at this example. This example over here is for a quadratic. Okay. Now in this example over here, we are given that we've got 6, 17, 34, and we've got 57, and so on. Now, in the first question, they say, show that it is a quadratic number pattern. We need to show that. Now, if it is a quadratic number pattern, now you remember what we've just done here. It is a linear. So how do we see now it is a linear? A linear has the first difference here. It is common, which is it is the same. That is why we're saying it is a linear. Therefore, in a quadratic, the constant difference is gonna be the second one, not the first one. So that means a quadratic is going to have 2 differences. So we're going to have the first difference, which is not common, and we're going to have the second one, which will be common. Then now this is how we show that the sequence is a quadratic. So now let's begin, and we will look at this one here. So we're going to use the same method to find the difference. Okay, so we want to say this is T1, this is T2, this is T3, this is T4. We're going to say T2 minus T1 and T3 minus T2. Then we subtract, and then we subtract. Okay, so it's going to be 17 minus 6 must be 11, and 34 minus 17 definitely is going to be 17, and then 57 minus 34 must be 23. So now this one over here, it is known as the first difference, and it is not common. So now we continue and we find the second difference. So we do the same, we do this. So it's going to be 17 minus 11 must be 6. 23 minus 17 definitely is going to be 6. And then this one over here, we call it a second difference. And this one over here, it is constant, or it's common, so it's the same. All right, so this is how we show that this sequence over here that is given to us, it is a quadratic. Why? We have the second difference, and it is constant. So this is how we see that it is a quadratic. So we can also conclude here by saying therefore it is a quadratic. It is a quadratic. Okay, because it has a common difference. Let me just be specific which one, because there are two. It has a second common difference. Okay, so that is the reason why we're saying it is a quadratic. And then now we go to number B. That was the first question. This is number A. And number B says, write down the next two terms of the number pattern. Okay, so this one is easy. So what we're going to do here is that, so we know that the constant difference here is 6. So, and then it's 6. So that means, okay, let me teach you this part. How do we then get the next term here? It's easy, because to get the next term here, that means we are looking for T5 or T5 and T6, because they say the next two terms. Okay, so what we're gonna do is that for you to get the next term, you say 6 plus 11. So that is that is 6 plus 11 must be 17. Let me just throw this portion here. So that is 6 plus 11. You always add 6 plus 11, it's 17. 6 plus 17 is 23. 6 plus 23, and then you get the next term, that must be 29. Okay, and then you do the same also from here up to 6. All right, so you say 11 plus must be 11 plus 6 is going to be 17. 17 plus 17 is going to be 34. 23 plus 34 is going to be 57. Then 29 plus 57, then definitely the next term must be 86. Okay, so that one is 86, and then we move on. We continue. So we know that this is constant anyway. So again, we continue by saying 29 plus 6, 6 plus 29, and then definitely that must be 35. And then of course here we said 29 plus 57, and we've just got 85. So, 86. So we're going to say 35 plus 86. Definitely the next term must be 121. So this is how you get the next term. So our next two terms are 85 and 21. And we just say here, we've just got 80. Let me just use this color. We've just got 86 and we've just got 86 and 121. So we go to number C. Now we go to number C. In number C they say, hence determine the nth term. When they say nth term, meaning that we have to find the formula, and they say as well as the 100th term. Okay, how do we then get the formula? The general term for quadratic says Tn is equal to an squared plus bn plus c. We need to determine those. In fact, we need to determine the value of a, b, and c, and then we just substitute. Okay, so it's easy. We always use this formula here that says 2a is equal to the second difference, and then the other one is going to say 3a plus b. 3a plus b is equal to the first difference, and the third one is going to say a plus b plus c is equal to the first term. You always use this formula for quadratic. Let me try to erase this portion here. So that means in order for us to determine this, we're going to use this value, which is 6, 11 for first difference, 6 for T1, 6 for second difference, 11 for first difference, and 6 for first term. Now let's go. So in the place of that is the second difference, we're going to put 6 and we divide by 2 in both sides. So that the value of a must be 3. So we come to this one. Now that we've got a is 3, so we're going to substitute the place of a here. We're going to put that 3 as well, plus b, but in the first that is the first difference must be 11. So 3 times 3 is 9 plus b equal to 11. So b is equal to 11 minus 9. Therefore the answer must be 2. So and then we take a over here and b over there, and then we find c. So let's go now. So it's going to be 3 and then plus 2 plus c, and the first term must be 6. So it's going to be 5 plus c is 6, and c is going to 6 minus 5, which is 1. And then we are done now. We're gonna just come to this formula and then we substitute. So therefore Tn is equal, in the place of a, we're going to put 3n squared plus 2n and then plus 1. So this is the formula. And here they say as well as the 100th term, so it's easy. Then we just say therefore in the place of n we're going to put 100, and then whenever we see n we just put 100. So whenever we see n we just put 100, and then we just work it out, and then we get the answer of 3,201. So must be it's 13, yeah, it's 30,000. So this is our answer. So we go to the last one. They say which term which is equal to 162. So when they say which term, this question is easy. They're just asking us the number of terms. That means we have to determine n, and then in the place of tn we're going to put 162. We're going to use this formula. So this formula says Tn is equal to 3n squared plus 2n plus 1. In the place of Tn, I'm going to put 162, and then 3n squared plus 2n and plus 1. So plus 1. And then we just work it out. So we're going to transpose 162 to that side. So we equate it to 0. Must be 3n squared plus 2n then plus 1 minus 162. So that means you're going to end up having 3n squared plus 2n minus 161. Okay, and then we try to factorize this portion here. So the factors of 3n must be 3n, and n. So for 161 must be 23 times 7. 23 times 7 is going to give us 161. And of course 23 is the bigger number, so we should make a 23, sorry, it must be 23, not 27, 23, and then must be plus, and this one must be negative. And then we just work it out. We equate each brackets equal to 0, so that must be 3n plus 23 equal to 0, or n minus 7 equal to 0, and then must be 3n is equal to negative 23. We divide by 3 in both sides, so for negative 23 over 3. So on that side, let's see what we've got. So that is must be 7. Guys, the number of term will never be negative, so the correct answer, therefore, it is n is equal to 7. Okay, so we say but n, it cannot be a negative, and then therefore n is equal to 7. So I hope we are done now in this question. That was the last question. Let me just take one more example, just one more example. Okay, without any further waste of time, let's look at example 2. So in this example here, we will be looking at this sequence, the first 4 terms, 45. Now the question says we need to solve for x, so it's easy. This one we're going to this is t1, this is t2, this is t3, and this is t4. So we're going to just subtract t2 minus t1 must be 9, and x minus 15 must be x minus 15. then 45 minus x must be 45 minus x, and then we continue. Remember, this is a quadratic, so we've got the first difference, and now we're looking for the second difference. So we've got this portion must be x minus 15 minus 9. So we're gonna have, that is x minus 15 minus 9, and then another one is going to be this portion minus this one. All right, so let's go. So it's going to be 45 minus x and minus into x minus 15. All right, so now how do we then find the value of x? It's easy, guys, because we always saying that the constant difference, which is the second difference, is the same, meaning that 6 is the same as this 6, and 6 is the same as that, and 6 is the same as that. Everything here, guys, is the same. So now that means we can equate, that is, this portion we can say is equal to this one because they are the same. When we say it's common, we mean they are equal. All right, so it's going to be 6 and 6 here. So meaning that over here we're going to do the same. So that means this one over here is the same as this one. That is the rule for quadratic. So that means two of them, they are the same. We're going to equate them together. Okay, so that means it's going to be x, which is 15 minus 9, is equal to 45 minus x and minus x and 15, and then we just work it out. So we're gonna have x and negative 15, negative 9, and on the side we're gonna have 45 minus x. We open these brackets with this negative sign. It's going to be negative x and plus 15. So on this side when I have that is 15 and 9, it's going to be x minus 24, and then on that side we've got 45, so that must be 45 plus 15 is going to be 60, and then x and x must be negative 2x. So we collect like terms. So here we are going to take this one to the side and we change the sign, and we take 24 to that side and we change the sign. So we're gonna have x plus 2x and 60 plus 24, so must be 3x, and 60 plus 24 is going to be 84, and then we divide by 3 in both sides. Therefore the value of x must be 28. So now we can go back there. That means over here, so that means here it's going to be 28, and 28 minus 15, and 45 minus 28, and then you also work it out over here, and then you get the value of, which is just the whole number. So we are done now. Thank you so much, guys. So after this example, now I will be taking the questions, which is the challenging questions over here, and we see that how do we then go about tackling these questions over here.